Okay, we are recording now. And here's my notes for chapter 4. So today, like I said, y'all, we're going to do 4.1. And so 4.1 talks about divisibility. So in chapter, at least in this section, y'all, we're going to talk about some divisibility tests. But what does it mean for it to divide? And it says for any whole numbers a and b where b is not equal to the number 0, B divides A if and only if there is a unique number Q such that A is equal to B times Q. Okay, so we're saying that A is said to be a divisor of B if the remainder is 0. So just so that we understand what that means, and I know most of us do already kind of have an understanding of this here, but I just want to kind of give an example. It says A is said to be a divisor of B if the remainder is 0. So let me think of a number B like, oh, I don't know, maybe the number, say, 24. Okay. Oh, come on, pen. 24. I'm going to say that's my number B. Now, I want to find a divisor of 24. All that means is what numbers can I pick that's going to go in nice and neat into 24? So I don't know. Suppose we pick 3, right? And the reason why we're going to say that A is a divisor of B, because when we divide this thing out here, my remainder happens to be 0, right? That's what we mean by it's a divisor, okay? Now, the next part here says an even number is a number that has a remainder of 0 when divided by 2. So y'all, one of the things that I learned when I was back in school, I actually took a class called, sorry about this, I actually took a class called number theory back in the day, and we talked about some of these divisibility tests. But one of the things I remember, and we do it in other classes too, but even numbers always end in a 0, 2, 4, 6, and 8. They're always going to end in one of those kind of numbers there, right? So if it ends in a 0, 2, 4, 6, and 8, then I know it's going to be an even number, okay? So odd numbers is a number that has a remainder of 1 when we divide it by 2, right? So if I think of the number 7, when I divide it by 2, it goes in 3 times. That's 6 with a remainder of 1, right? So that's what we mean by odd numbers. They all have a remainder of 1, okay? So I'm going to go through a few problems that I have here. And it says, if you multiply an even number by 2, and then we add 1, is my answer going to be even or odd? So I want to think of a couple of even numbers, okay? So I'm going to think of, like, say the number 6. I'm going to think of the number, I don't know, 18. Well, maybe not 18. I don't want it to be a multiple of 6. Okay. So let's pick another number that's not a multiple of 6 that's even. Oh man, 28. 26 doesn't go into 28, okay? And so it says, look, if we multiply an even number by 2 and then we add 1, is our answer even or odd? Okay, so this is what we're going to do. We're going to multiply it by 2. That's going to give me 12. That doesn't look like a 12. It looks like an R. We're going to get 12. And then if we add 1, we end up with 13. Is that answer even or odd? What do you think? That's odd, right? Okay, let's try the same thing here. I'm just trying a couple of numbers here. So 2 times 28, if y'all want to use your calculator, we can. 28 times 2 is 56, right? And if I add 1 to it, I'm getting 57. Again, it looks like my answer is going to be odd, right? Okay. Now, the next couple of questions, y'all, and there's like 5 questions here. I just want to kind of zoom in on this part. And it says 4 is a multiple of 36. Is this statement true or false? So what I want you to think about, it says 4 is a multiple of 36. If I were to think of a multiplication table, right? And we have our multiplication table. I'm going to pull it up again real quick just so that I can see it over here. Oh, where is it? Up here at the top. Okay. Now, my multiplication table only goes to 20, right? It only goes to the number 20. But I'm thinking about the number 36, okay? So if I were to think of the number 36, so here's 36. The first one is going to be 36. The next one's going to be 72. 36 times 3, I want to say, is going to be something like 108, right? The question that it's asking me is 4 a multiple of 36. Would the number 4 be in that list? And no, it wouldn't, right? Because the smallest number I have in my list, y'all, is the number 36, right? So is 4 a multiple of 36? Or 4 is a multiple of 36? Is this statement true or false? It would be false. Now, 4 is what we would call a factor, but there's a difference between it being a factor and it being a multiple, okay? Now, the next one says 7 is divisible by 28, okay? So again, what do they mean by that? That means if I were to take 28, would 28 go nice and neat into 7? No, it wouldn't. Why? Because this number here is bigger than that number. So this would also be false. Now, if it was switched the other way around, if it would say 28 is divisible by 7, that we would know is true, because if I look at my multiplication table again, and guys, I'm just going to pull up my multiplication table again. If it was written the other way, then I would know that that's true, because 28 is one of the multiples of 7, right? But because the way the question is phrased, get this back over here, because the way the question is phrased, 7 is divisible by 28, I know that's false, okay? Now, look at the next one. 5 is a factor of 35, right? Okay, so again, I want to know, is this statement true or false? So if I were to think of the number 35, right, and I were to look at my multiplication table, so I'm going to come back to my multiplication table. I'm going to look at the number 5, and I'm going to see, is 35 one of those numbers? Yeah, it is. So I know that's going to be true, okay? Okay. Okay, same thing here with the next one. "15 is divisible by 5. Okay, 15 is divisible by 5. So again, I would do the same thing here. Remember what that means. Does 5 go into 15 nice and neat? Yeah, it does, right? It goes in 3 times. So again here, y'all, I'm going to say that's true. And then when the last question says 64 is a divisor of 8. Okay, so again, I just want to make sure that I understand, because when the numbers are switched around, it may make sense one way and it may not make sense another way. So the reason I'm saying that is when I look at this problem here and it says 64 is a divisor of 8, what that is asking me is, if I were to take the number 64 and I were to divide it into the number 8, would it go in nice and neat? No, it wouldn't. Why? Because that number is bigger than that one. So it's false. But I just want to mention something here, y'all. I'm going to kind of erase some of this mess here. And I'm going to write this in red. 8 is a divisor of 64. That would say, does 8 go into 64 nice and neat? And I know that would be true, okay? So in order for my number to be a divisor, number one, my number has to be smaller than whatever I'm dividing it into, right? And then it has to go in nice and neat with no remainders. Okay, so the second part here, y'all, we have a couple of little theorems or little rules, and it says for any whole numbers A and D, if D divides A, and then N is any whole number, then D is going to divide N times A. So just to give you an example, what does that really mean? Let me think of 2 numbers. Okay, so let's think of my number A. Let's pick up kind of a bigger number, like say 24. And let's think of my number D as, I don't know, something like 3. Okay, this is what it's saying. D divides A. So 3 goes into 24 nice and neat. Yes, we know that's true because it's going to go in 8 times. Now it says if that's true, and then we take any whole number. So let me think of a whole number. We're going to keep it small here. Let's think of, say, 2. Okay. What this is saying is that 3 is going to divide 2 times 24. And 2 times 24 is 48. And so it's just saying that 3 would also divide 48. That's all the theorem is saying. It's just saying if 3 divides this number, then it's going to divide any multiple of that number. Okay. All right. Another couple of ideas that we have here. The first one says if D divides A and if D divides B, then it's going to divide the sum of those 2 numbers. Again, let me think of a couple of numbers just because I want to show us an example. I think a lot of times it's easier if we see actual numbers as opposed to just like letters A, B, and D or whatever. So I'm going to think of my number D as, say, being the number 2, and I'm going to think of my A being the number 6, and I'm going to think of my B being the number 8. Okay, so look what it's telling me. Right here, y'all, it just says this number will go into 6, nice and neat, and it'll also go into 8, okay? What the first theorem is telling me is if we were to add 6 and 8 together, that my number 2 would divide those numbers when I add them up. 6 and 8 is going to give me 14, and yeah, 2 does divide 14, okay? That's all that part's telling me. Now, the second one says if D divides A, but it does not divide B. That's how I read this piece right here, y'all. Okay, that means it does not divide B. Guys, I'm going to try changing my battery on this little pen because it keeps messing up a lot. So give me un momento, por favor. Let me see. I think I have another battery here. I thought I did. Oh, man. Let me see. Yes, we do. Let's see. All right. Let's get this guy going. And let's see if this works. Okay. Moment of truth. All right, there we go. Okay, it seems to be working. Okay, so it says if D divides A and it does not divide B, then it's not going to divide the sum. Okay, so let's think about this for a minute. Again, y'all, for part B, I'm going to think of my number D as still 2. Okay. I'm going to think of my number A as, say, 6. And now I need to come up with a number B that is not divisible by 2, like, say, 7. Okay. So notice 2 does go into 6, but 2 doesn't go into 7. All this is telling me is that 2 will not divide 6 plus 7 because 6 plus 7 is going to give me 13 and 2 doesn't divide that out. That's all that piece there is telling me, okay? So again, I just kind of want to go through these ideas so that we have an understanding, because I think a lot of times when we have these kind of general rules like D and A and B, unless I can see it with actual whole numbers, it makes it a whole lot difficult for me to figure out, okay? So let me clean up some of this mess here. Okay, I'm just going to clean up some of this. And now I'm going to do part C. Okay, here's part C. It says if D divides A and D divides B and A is bigger than or equal to B, then D is going to divide the difference. Okay, I'm going to keep this simple again. I'm going to say my number D is 2. I'm going to say my number A is, say, 10. Now my number B has to be either smaller than 10 or equal to 10. So let me pick another number that's smaller than 10 or equal to 10, like, say, oh, I don't know, 6. Okay. Now it's saying D is going to divide the difference between those two. So 2 is going to divide 10 minus 6. 10 minus 6 would be 4. Yeah, that's true too. Okay. All right. And then the last two say if D divides A, but it does not divide B, and A is bigger than B, then it's not going to divide the difference. Okay, so again, let me stick with my same numbers. It goes into 2. It's not supposed to, I'm sorry, 2 goes into 10, but it's not supposed to go into 6. So let me change this 6 to, like, oh, I don't know, say a 7. Okay, now all it's telling me is that 2 is not going to divide 10 minus 7. Okay, That's all that that's really telling me right there. Okay. And the same thing, y'all, would work also for part E. Again, look, it's telling me that 2 does not divide A. Okay, so let's keep D being 2. Let's change A to be 5, but it does divide B. So I'm going to make that 8. And I'm sorry, A needs to be bigger than B. So let me change this to say, oh, I don't know, a 4. Okay. Now it's just saying that 2 is not going to divide A minus B. 2 is not going to divide 5 minus 4. That's true. 2 would not go into 1. Okay. So I just wanted to kind of go over some of those general rules there because we're going to use that as we go through 4.1. Okay. So second piece I have here, y'all, is something called the divisibility test. So all this is telling me is how do I know if I can divide a number by 2, by 5, by 10, by 4, by 8, by 3, by 9, by 6, and I even have one here for 11. Okay, so let me zoom out here. It says a divisibility test for 2. It says a whole number is divisible by 2 if and only if the unit's digit is divisible by 2. That is, if and only if the unit's digit is even. All that's telling me, y'all, is that if my number ends in a 2, 4, 6, or 8, we can divide it by 2. Okay. A divisibility test for 5. It says a whole number is divisible by 5 if and only if the unit's digit is divisible by 5. That is, if and only if the unit's digit is a 0 or 5. So it has to end in either a 0 or a 5. Okay. How do I know if a number is divisible by 10? The unit's digit is 0. It has to end in a 0. Okay, so again, one thing I want to point out here, y'all, I was talking about my multiplication table. I'm going to come back and I'm going to click on my multiplication table because I want to show you guys something. Look at the multiples of 2. 2, 4, 6, 8, 0. 2, 4, 6, 8, 0, right? They all end in either a 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, right? Look at the 5s. The 5s, they either end in a 5 or a 0. 5 or 0. 5 or 0, right? Look at the 10s. The 10s all end in zeros. That's all that those divisibility tests are really telling me here, okay? So Theorem 4.6 says a number is divisible by 4 if and only if the last 2 digits of the number represent a divisible by 4, okay? So what that's telling me is I can divide a number by 4 if the last 2 digits can be divided by 4. I'm going to scroll back to my multiplication table real quick. And I want to look at, I guess we have our 2-digit numbers. But what it's telling me is that even if I had a bigger number, as long as the last 2 digits can be divided by 4, then the whole thing can be divided by 4. Okay. Let's see, what else do we got here? Divisible by 8. It says a number is divisible by 8 if the last 3 digits can be divided by 8. Okay. And then divisibility test for 3. It says a whole number is divisible by 3 if and only if the sum of its digits is divisible by 3. So look, y'all, I want to show you something. I remember when I learned about this divisibility thing by 3, it always kind of seemed kind of cool to me. So look, I'm going to come to my 3s here. Here are my 3s. So I'm going to pick a number here by 3. Like I'm going to pick the number, say 42. I know 42 is divisible by 3 because it's in my chart, right? But what I'm trying to point out here, y'all, is if the number 42, if I want to know it's divisible by 3, the way I could check is I would take 4 and 2, add those numbers together, we get 6. Because I can divide 6 by 3, that tells me I can divide 42 by 3, okay? And the same thing for 9. It says a number is divisible by 9 if and only if the sum of the digits of the whole number is divisible by 9. So again, let me come back to my multiplication table, okay? And let me go to my 9s, which are right here in the middle. I'm going to kind of zoom in on them. And I'm going to take the number, say, I don't know, let's try 117, okay? Here's 117. So if I'm thinking about the number 117, the way I would figure out if it's divisible by 9, I'm going to take 1 plus 1 plus 7. That's equal to 9. So since I can divide 9 by 9, then I can divide 117 by 9, okay? All right, we got a couple more. and it says a whole number is divisible by 6 if you can divide it both by 2 and 3, right? Because we know 2 times 3 gives me 6. So if I can divide it by 2 and I can divide it by 3, then we can divide it by 6. And divisibility test for 11. Okay, it says here's an easy way to test for divisibility by 11. Take the alternating sum of the digits in the number read from left to right. If that number is divisible by 11, so is the original number. So it gives me an example. Here's the number 2728. So what we mean by the alternating sum, we're going to take the first digit 2, we're going to subtract the digit 7, we're going to add the third digit 2, we're going to subtract the last digit 8. So 2 minus 7 is a negative 5 plus 2 minus 8. Negative 5 plus 2, if I owed you $5 and I only had 2, I would still owe you 3. And negative 3 minus 8, if I owed you $3 and I owed you 8, I would owe you 11. And because I can divide this number by 11, then we can also divide that number by 11. Okay? So this problem here says, without using a calculator, test the number 15,810 for divisibility by 2, 3, 4, 5, 6, 8, 9, 10, and 11. Okay, so let's see if we can figure this out. So first thing I'm going to check to see if it's divisible by 2. Okay, so y'all, in order for it to be divisible by 2, it has to be an even number, meaning it has to end in a 0, 2, 4, 6, or 8. So can we divide it by 2? Yeah, we can, right? Why? Because it ends in a what? It ends in a 0, right? Okay, so can we divide it by 2? We're going to say yes. Okay. Now, we're going to check 3. Can we divide it by 3? Y'all, the way we check for 3 is we're going to take those digits and we're going to add them together. 1 plus 5 plus 8 plus 1 plus 0. So 1 and 5 is 6. 6 plus 8, anybody know? 14? 14 plus 1 more? 15. Can we divide 15 by 3? Yes, we can, right? Then we can divide the whole number by 3. Okay. Part C, we're going to check 4. Okay. If we want to know if we can divide this thing by 4, we have to look at the last 2 digits, y'all. The last 2 digits are 10. Does 4 go into 10 nice and pretty? What do you think? No, it doesn't, right? 4 doesn't go into 10. Okay, so no, doesn't divide by 4, right? 4 is not going to work. Okay, the next one we're going to try, y'all, part D, we're going to try 5. So remember, if it's divisible by 5, it has to end in either a 0 or a 5. Yeah, it ends in a 0, so 5 we're good. Okay. 6, okay. If it's divisible by 6, I will know if it's divisible by 6 if it worked for 2 and it worked for 3. Yes, then it also works for 6. Okay. Part F, I'm calling it part F. I want to know, can we divide it by 8? I should be able to divide it by 8 if I look at the last 3 digits. So the last 3 digits are 810. So I would want to know, does 8 go nice and pretty into 810? So look, y'all, if I divided this out here, that would go in once. Okay. I would bring down my 1, but it doesn't go into 1. I would bring down my 10, but 8 doesn't go into 10. So no, I can't divide it by 8. Okay. Okay, the next one I'm going to check is 9. A, B, C, D, E, F, G, right? Okay, 9. So 9, y'all, says we're going to add up the digits again. Well, we already did that, right? We got 15. If this number can be divided by 9, then the whole thing can be divided by 9. But 9 doesn't go into 15. So no, 9 doesn't work. Okay. A, B, C, D, F, G, H. H says, let's check 10. We should be able to divide it by 10 if it ends in a 0. And yeah, it ends in a 0, so we can divide it by 10. HI. And now we're going to check 11. So y'all, again, I just want to kind of go over this part here. The way I would check to see if I can divide it by 11, I'm going to take the digits one at a time. I'm going to go 1. The second one, I'm going to subtract it, -5. The next one, I'm going to add it, +8. The next one, I'm going to subtract it, -1. The last one, I'm going to add it. That's always going to be my process. First one minus the second one plus the third one minus the next one, and so on and so forth, okay? If the answer that I get here can be divided by 11, then the whole thing can be divided by 11. Okay, so look, 1 minus 5. If I have $1, but I owe you 5, I still owe you 4. Okay, I'm not going to worry about the 0 because it's just a 0. If I owe you $4 and I have 8, I'm still left with 4. And 4 minus 1 is going to give me 3. So 11 does not go into 3. So then I can't divide that thing there by 11. Okay. And that's how I'm going to check my answers to see if I can divide it by 2, 3, 4, 5, 6, 8, 9, 10, and 11. Okay. All righty. So I'm going to keep scrolling along here, y'all. And the next question, and I wrote part B twice also, I apologize. Okay. So that was just my bad. I just put part B twice. But it says, can a parking lot be designed to accommodate 3,562 cars can be divided into 11 equal rows? Okay, so I think the idea here behind this problem, y'all, we're just asking ourselves, does 11 go nice and neat into 3562? Okay, so I'm going to show you the way I believe the book wants you to kind of do this. And then I'm going to show you, if I was sitting in your shoes, this is probably what I would do. But remember, the divisibility test for 11 says, write the number 3, subtract the second number 5, add the third number 6, subtract the last number 2. Okay. If I have $3 and I owe you 5, I still owe you 2. Okay. If I owe you $2 and I have 6, I'm still left with 4. And 4 minus 2 is 2. Since 11 does not go into 2, then 11 won't go into that number nice and pretty, right? So I'm going to put no. They're asking, in these problems, y'all, they're actually asking me to use the divisibility test, right? But if I was probably sitting where you're sitting, what I would probably do here, y'all, is I'd probably take my number 3562 and I would divide it by 11. And the fact that it doesn't go nice and pretty tells me, no, I can't do it, right? But the idea here is they're actually asking me to use that divisibility test, okay? That's why I did it that way. Okay, so again, I wrote part B twice. So let me go ahead and go to part C. And it says, can a theater charging $6 per person for admission to a play take in exactly $2,060 for a night's performance? Okay, what they're asking me to do here in this problem, y'all, is does 6 go nice and neat into that number? Now remember, the divisibility test for 6 says if you can divide it by 2 and you can divide it by 3, then you can divide it by 6. So I already know that I can divide it by 2 because it's an even number. It ends in a 0. If I wanted to know if I could divide it by 3, what I would do is I would add all the number or all the digits up, okay? 2 plus 0 plus 6 plus 0 is 8. If I can divide 8 by 3, then I can divide the whole number by 3. But 3 does not go into 8. So because I can't divide it by 3, I also can't divide it by 6, right? And again, what I would probably do if I was sitting where you're sitting is I'd probably go 20, 60, right? That's the number I have, I want to say. Yeah, 20, 60. And can I divide it by 6 nice and neat? No, because that's what I end up with, right? In order for it to be nice and neat, I would have to be no remainder, right? So no decimals, no point something, right? Okay. So the next problem I have here says, place a digit in the square, if possible, so that the number 652,600 blank 6 is divisible by 4, and it's also divisible by 8. Okay, so this is what we're going to try to figure out, y'all. In order for a number to be divisible by 4, the last 2 digits have to be divisible by 4. So I'm going to have a blank and a 6, okay? Now, I want to think of my multiplication table. So I'm going to scroll back over here to my multiplication table, okay? And I'm going to look at the 4s. Here we go, okay? So if I look at the 4s, remember, I know it ends in a 6. So look, I could put a 16, I could put a 36, I could put a 56, I could put a 76, right? Those are just some of the options that I have, okay? So here's my 4s: 16, 36, 56, and 76, okay? So if I come back here and it says what number will make, or what digit will make the number divisible by 4? Well, I would definitely say I could include a 16, right? I could do that. And it says and divisible by 8. So now if it's going to be divisible by 8, I have to look at the last 3 digits. So 616, and I want to know, does 8 go nice and pretty into there? So y'all, what I would do is I'd take 616. Can I divide that by 8? Yeah, look, it goes in 77 times, right? So what number am I going to put right here? I'm going to put the number 1, right? And that's how I would check it. But I know I could go a 1, I could go a 3, I could go a 5, I could go a 7, I could probably go a 9. But I'm going to go through it and I'm trying to do it systematically, right? I'm not just going to kind of like blindly guess. I'm going to go from the smallest to the biggest and see which one works, okay? Okay, so now I got another problem here, and it says fill in the following blanks with the greatest digit that makes each statement true. So part A says 3 is going to divide into 780 and change, right? So we want to know what that change is going to be, okay? So y'all, reminder, if I'm dividing by 3, that means when I add up the digits, whatever answer I get can also be divided by 3. So look, I'm going to take 7 plus 8, which is 15. Okay, I know 3 goes into 15. So far we can divide that piece by 3, but I need to figure out what's the biggest digit I could put at the end, okay? So y'all, to find the biggest digit, what I'm gonna do is I'm gonna pick what's the biggest digit we have. When I think of my numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, that's what I'm looking for. Which is the biggest number I can use there, right? So y'all, what I would probably do is I'd say, well, let me try the biggest digit. The biggest digit is a 9. If I add a 9 here, that's going to give me a 24, and I can divide that by 3. So yeah, I would put a 9 right there. Okay. Now, let me look at part B. Okay. Part B says 6,700, it's actually 67,003 because then there's a blank there. Okay, so look what I'm going to do. I'm going to pick 6 plus 7 plus 0 plus 3. Okay, so if I start to add these numbers together, 6 and 7 is 13, and another 3 is going to give me a 16. Okay, so y'all, I'm trying to find the biggest number that I can put in this last spot right there. Okay, so that I can divide it by 9. Okay, I want to think of the multiples of 9. What I mean by that, y'all, is if I come back over here and I look at my multiplication table, I want to look at the numbers of 9, the multiples of 9, I'm sorry. So look, we have 9, we have 18, we got 27, 36, 45, so on and so forth, okay? So since the number that I have right now is 16, I want to think of, okay, what are other multiples of 16 or multiples of 9 that are going to be bigger than 16, right? So obviously the first one I would think of would be 18, but I might also try, say, 27, okay? So if I think about this, if I put a 2 at the end, right, that would give me an 18, okay? So, and I know I can divide that 9 by 18 or 18 by 9. But I want to know, what would I have to add to 16 to get 27? Anybody know what would we have to add to 16 to get 27? 16 plus what gives me 27? Anyone know? 16 plus what gives me 27? I'll give you a hint. What's 27 minus 16? Anyone know? 27 minus 16? 11, right? Okay, but that right there, guys, has 2 digits. So I can't do that, right? So what's the number I'm going to use? I'm going to use a 2, right? That's all I'm trying to figure out here, okay? All right, let's take a look at the next one. So the next one I have is 11 going into blank 767. Okay, so look, let me clean up some of this mess here because I got a whole lot of it. So much better when my pen works. Okay, so 11 is supposed to go into blank. Okay, and then 767. Okay, so y'all, the way I do this piece, remember, whatever that first number is, I'm going to leave it alone. And then I'm going to subtract 7, I'm going to add 6, and I'm going to subtract 7 again. Because we got to do that little alternating bit, right? So look, if I do this here, minus 7 plus 6, if I owed you $7 and I had 6, I would still owe you 1, okay? If I owed you $1 and I borrowed another 7, I would owe you 8, okay? So I need to figure out what number can I put here so that when I subtract 8 from it, I can divide that by 11. So y'all, this is not something we typically think about, I think too much, but if I put the number 8 here, 8 minus 8 would give me 0, and I can divide 0 by any number, including 11. So I would say my first number here needs to be an 8, okay? All right, for part D, it says 5 is going to go into 6,060 and something. Now again, remember, we're looking for the greatest digit. So y'all, the way I know if I can divide a number by 5, it has to end in either a 0 or a 5, which is the bigger of the two. 5 is, right? So I'm going to put a 5 right there, okay? All right, now let me do part E. So I'm going to clean up some of this mess again, okay? And let me do part E. Part E. Oh no, pen, come on, there we go. Part E is 6 is dividing into 7,000 blank 20. Okay, so first thing, y'all, I know if I can divide a number by 6, I should be able to divide it by 2, and I should be able to divide it by 3. So I already know that I can divide it by 2 because it ends in that 0 there. Okay, so we're good for that part. Now, in order for me to be able to divide it by 3, I got to take the digits and add them up. 7 plus blank plus 2 plus 0. So 7 and 2 is going to give me 9. 9 plus something, okay? And so I'm trying to figure out what's the biggest number I could put there. So again, y'all, I'm looking at my digits that I have here. The biggest number that I could put so that I can still divide it by 3 would be another 9. Because if I put a 9 right here, 9 and 9 is going to give me 18. And yeah, I can divide that by 3. So right here, y'all, I'm going to put a 9. Okay. I'm sorry, I didn't put the 5 right here. And then finally, I have part F. 8 dividing into 500 or 5,840 something. Okay. So look, let's check that one. Okay. So 8 divides into 5,840 something or another. Okay. So first thing I want to figure out here, I know if I can divide a number by 8, if I can divide the last 3 digits by 8. Okay. So really what I'm trying to figure out is 8 is going to go into 840 and what? Well, I already know that 8 goes into 8. I know that part. So really what I'm trying to figure out is 8 goes into 40 what? So y'all, all I would do, I'd come back, I'd look at my multiplication table. Here's 8. 8 goes into 40 what? 48. It goes into 40, but it's, since I'm looking for the biggest digit, it goes into 48. So right here at the end, y'all, I would just put an 8. Okay. And that's how I'd figure this thing out. So one thing I really want to emphasize, y'all, in these problems, what I'm really using a whole lot, I'm using my multiplication table. Why? It's real basic, but it's really, really helpful in me figuring out how to do these problems, okay? All right. So we got a couple other problems here. And it says, justify, why does 7 go into 210? Now, y'all, these are multiple choice problems. So what I'm really looking for here is which one of those choices best gives me the explanation. Okay, so if I look at my first choice, it says 210 is 7 times 30. Yeah, that's true. Okay. The next one says 210 is equal to 7 plus 30. That's not true. That's 37. Part C says 210 minus 30 equals 7. No, I know that's not true. So I would pick choice A, right? Because that was the true statement. Now, for the next one, it says 23 goes into the sum of 23 and 69, okay? Choose the correct answer below. So, y'all, we talked about this. This was one of the little theorems that we had earlier. So I'm going to kind of zoom back up here just because I want to show you where I'm getting this thing from. Here we go. When I look at theorem 4.2 and I look at this first one here, it says if D divides A and D divides B, then it's going to divide the sum, okay? So when I look at that theorem and I scroll back to my particular problem that I have right over here, if it divides the sum, then that means because it divides both each of those numbers individually, okay? It divides 230 and it also divides 69, okay? Okay, so the next part here says justify. Why does 35 divide the product, which means multiply, 3 to the 4th times 5 to the 6th times 7? Okay, so I'm going to look at each of the choices that I have here. And it says 35 divides 3 to the 4th times 7. And so, y'all, if I was going to check this thing out, the first thing I would do is I would say, okay, what is my number 3 to the 4th? I'm going to go to my scientific calculator just so that you can kind of see what I'm doing. 3 to the power 4 would mean take the number 3. Here's my little exponent button. Put a 4. Hit equals. We're going to multiply that number now by 7. I'm coming up with 567. I want to know, can I divide that by 35? No, I can't. So I know that choice A does not make any sense for me. Okay. Now, I want to look at choice B. Okay. When I look at choice B, I want you to notice, y'all, here we had the number 5. But how many 5s did we had? We had 6 of them, right? Because that's why I got that power there. Now, I want you to notice they moved one of the 5s to the outside. So if I had a total of 6 5s and I moved one of them over, I would now be left with 5 of them. Okay. The second thing is they took this number 7 here. They also moved it to the front. I didn't touch those 3s, so those 3s are right there. And I know that 5 times 7 gives me 35. So my choice here, y'all, would be B, because 35 goes into 35, and so it's going to go into any multiple of 35, okay? Okay, part D says justify. Why does 23 not go into 230 plus 22? Okay, first question. Do y'all think 23 goes into 230? Yeah, it does, right? Okay, so I'm going to look for when does 23 go into 230? Right there, okay? Does 23 go nice and pretty into 22? No, it doesn't, because 22 is too small. And look, it doesn't go into 22. So my choice here, y'all, would be C. Okay. Okay. So for the next part that I have here, y'all, it says find a whole number solution that makes each of the following true. Okay. So it says divisible by 2 and by 3, but not by 5. Here are my choices, y'all. These are my choices for part A. Is there a number that I can divide both by 2 and 3, but not by 5? Okay. So if I were to look at the first choice, 15. Well, I know I can divide 15 by 3, but I can't divide it by 2. That doesn't look good. Okay. 30, I can divide it by 2. I could also divide it by 3, but it's not supposed to be divisible by 5, but 5 goes into 30. So I know that's not true. Okay. Let's see, 56, I can divide it by 2 because it ends in a 6. Remember, as long as it ends in an even number, I can divide it by 2. Now, if I wanted to know if I could divide it by 3, I would say, what's 5 plus 6? That would give me 11. But I can't divide 11 by 3, so no, that doesn't look right. Okay, by 2 and by 3, but not by 5. Yeah, 2 goes into 24. 3 also goes into 24, but not 5. So my choice here would be D. Okay. Okay, now I'm going to look at part B. So part B says we want to make sure that we can divide it by 2 and by 4, but not by 8. Okay, so first question, can I divide 42 by 2? Yes, because it's even. I want to know if I can divide 42 by 4. So yeah, y'all, 4 goes into 42 13 times, okay? Now the question is, does 8 go into 42? No, it doesn't, right? So far, 8 looks like it's going to be my answer, okay? If I look at part B, I know I can divide 40 by 2. I know I can divide it by 4, but I can also divide it by 8. Let's see. 84, I can divide it by 2, yes. I can divide it by 4, yes. I can't divide it by 8, though. So it looks like I got 2 choices here. 84 can be divided by 2 and by 4, but not by 8. Yeah, so it looks like I got 2 choices here, y'all. So sorry about the noise. 42 and 84. And then 18, I can divide it by 2, but I can't divide it by 4. Okay. All right. And then there's a part C. We can divide it by 5 and 10, but not by 2. Okay. So by 5 and 10, but not by 2. Well, 35 can be divided by 5, but not by 10. 30, I can divide it by 5 and 10, but also 2. This one, I can't divide it by any of them. 50, I can divide it by 5 and 10 and 2. And so there is no whole number that's divisible by 5 and 10, but not by 2, okay? Okay, so now the next question says, a group of people ordered pencils. The bill was 55 cents. If the original price of each was 6 cents and the price has risen, how much did each cost? Okay, so I know that each pencil cost 6 cents and we spent a total of 55 cents, okay? So the cost went up a certain amount. We added a certain amount here. I'm going to call it X, okay? Now, y'all, when I think of the number 55 and I were to break down the number 55, what 2 numbers besides 1 and 55 go into 55? Anybody know? What 2 numbers multiplied at 55 besides 1 and 55? Let me ask you a question. Does 5 go in there? Right? 5 and what? And 11, right? 5 and 11. 5 and 11 go into 55. Okay, so look, y'all, I got 2 choices here. It says the original price was 6 cents and it went up. So number 1, I couldn't say it cost 5 cents because it used to cost 6 and it went up. How much did it go up to? It went up to 11 cents, right? And that's all I would do really to figure out that problem. Okay. All righty. Let me kind of keep moving along here and see if we can't figure out what's happening. Okay, so part A says if every digit of a number is divisible by 3, then the number itself is divisible by 3. So y'all, I want you to remember the rule for how can I check to see if a number is divisible by 3? If I add up all the digits and I divide that, and that number can be divided by 3, then the whole thing can be divided by 3. So let me think of a number where every digit can be divided by 3. So I'm thinking of multiples of 3, like say 9, 6, and I'll just keep it like that. I'll keep it simple. 9 and 6. I know I can divide all those numbers there by 3. I could put a 3 somewhere in there if I wanted to, but I'm going to keep it simple. If I can divide those numbers by 3, could I divide the whole thing by 3? Remember what we're going to do. We're going to add 9 and 6. That's going to give me 15, right? Now, guys, look, if we did include another 3 here, so say 396, we would have a 3 here. That would change that to an 18, right? Which I can still divide it by 3. So we know the statement is true. And the statement says, the statement is true. If every digit is divisible by 3, then the number itself is divisible by 3. Okay, so I'm picking D because that's what the statement says. If every digit of a number is divisible by 3, then the number is divisible by 3. It didn't say if only all the division, no, only if all the division, if only all of its digits are divisible by 3. It didn't say that. It said if every digit is divisible by 3, then the whole thing can be divided by 3. Okay. Now, part B says, if a number is divisible by 3, then every digit of the number is also divisible by 3. So remember, a number is divisible by 3 if you can add them all up, and if that answer can be divided by 3, then the whole thing can be divided by 3. So look, y'all, let me think of a simple number, 21, okay? If I think of 21, I know I can divide that by 3 because I know it goes in 7 times. But if I were to take 2 plus 1, that gives me 3. So that's how I know I can divide it out. But it doesn't mean that the numbers 2 and 1 could be divided by 3, okay? So let's take a look at the choices that I have. And the first one says the statement is false. The number 1,767 is divisible by 3, but the individual numbers are not. So let's take a look. Let's take 1 plus 7 plus 6 plus 7. So 1 and 7 is 8 plus 6 plus 7. 8 and 6 is 14 and 7 is 21. Okay, so yeah, look, here's another one. That number can be divided by 3, but the individual numbers can't. So I would say, look, choice A. Okay. Now, part C says a number is divisible by 3 if and only if the sum of its digits is divisible by 3. Okay. Let's see. So we got a couple of choices here. It says the statement is false. The number 1,000 or 137,367 is not divisible by 3. So let's see. 137,367. If I were to add those numbers up together, that's going to give me a 10, and that's going to give me another 10, and 1 and 6 is going to give me a 7, and if I add those numbers up, that's 27. Okay. Let's see. So it says the statement is false. The number 137,367 is not divisible by 3. That's not true because we can divide it by 3. It says the statement is true. It's not divisible by 3. That's not true either. This third one says the statement is false. A number is divisible by 3 if all of the digits are divisible by 3. That's what makes this thing false. Again, this number here, I can divide it by 3, but the individual digits themselves cannot be divided by 3, okay? All right. My next problem here, y'all, says if 55 divides n, what other numbers divide n? Okay, so I want you to think about that number. 55 divides into some numbers, so it's obviously got to be 55 or bigger, okay? We want to know what other numbers are going to divide n. So what I'm thinking about, y'all, are the factors of 55. So the factors of 55 would be 1 and 55. What other numbers multiply to 55? We did this a little while ago. 5 and 11, right? Okay. What other numbers that are going to divide n? 1, 5, 11, and 55, because those are all numbers that divide 55, right? Now it said, why do these numbers divide n? Because they also divide the number 55, okay? Okay, and so I think I got just one more problem here, y'all. So it says if the 5-digit number AA448 is divisible by 9, what does the number A represent? Okay, so one thing I want to mention here, y'all. When we're dividing a number by 9, the way we know we can divide a number by 9 is if we add up each of the individual digits. So I'm going to write A plus 4 plus 4 plus 8. Okay, and I want to see what I'm going to end up with. So A and A is going to give me a 2A, because there's 2 of them there. Okay. 4 and 4 is 8, and 8 and 8 is going to give me 16. Okay. Now, I want to think of the multiples of 9. So I'm not going to go back to my multiplication table, y'all, but if I had 9 here, I know this one would be 9. I know this one would be 18. I know this one here would be, say, 27. Okay. So I'm thinking about these numbers here, okay? 9, 18, and 27. Now, y'all, I'm probably going to start right here because 9 is already smaller than 16, okay? So I want to think of, okay, suppose I used the smaller number, 18, okay? And I wanted to say 2A plus 16 equals 18. Y'all, this is just a basic kind of algebra problem, right? If I subtracted 16 on both sides, okay, that would leave me with a 2A. 18 minus 16 is 2. And I divided everything here by 2. A would be equal to the number 1. Okay. So I could say, hey, you know what? A could be the number 1. That looks like it's a reasonable choice. Now, if I were to say, okay, well, look, I know we could do it with 18, but could we do it with, say, 27? Then I would say 2A plus 16 equals 27. And if I were to subtract 16 on both sides, okay, that would leave me with 27 minus 16 would give me 11. And guys, I cannot take 11 and divide it by 2 nice and pretty. So what am I going to do? I'm going to stick with A being the number 1. So right here, y'all, my number A would have to be the number 1. That's the only choice I have, right? And the same thing would happen, y'all, with 36. I just want to kind of show you real briefly, just because sometimes people ask, well, why couldn't we use 36? And I think it's a reasonable question, so let me show you. If I did 2A plus 16 equals 36, and I subtracted 16 on both sides, 36 minus 16 would give me 20. When I divided it by 2, A would be the number 10. But A has to be a single digit, and 10 has 2 digits in there, right? So that's why I got to stick with 1. And I couldn't do anything more than that, right? Because it's just going to get bigger and bigger and bigger. So yeah, y'all, for this one here, A is going to be equal to 1. Okay, so for that right there, you guys, is 4.1. Let me go ahead and stop recording here. Let's come back over here. Stop recording.